I'm going to be solving some exponential equations today. There are two situations involved with exponential equations. In an exponential equation, there's the variable is in the exponent, or variables are in exponents in more advanced cases, super advanced cases. There are two situations that are convertible to a common base. Some of them are. Others are not convertible to a common base. Now with the Swakowski-Cole textbooks, they use natural log if the base is e. They use a common logarithm for any other base. Okay? So if convertible to a common base, you don't have to use a logarithm. But logarithms will work for any exponential equation. So not all exponential equations can be done this way. But all exponential equations can be done using logarithms. So we'll use example 1 to illustrate this. So there's option A. That's the easiest because 2 and 128 are both convertible to a power of 2. 128 is equivalent to 2 to the 7th. Now, that being the case, if this equals this, and the base equals the base, that requires the exponent to equal the exponent. 3x plus 13 is 7. Subtract your 13. And 3x is negative 6. Divide off the 3, divide off the 3. X is negative 2. Now, what would have happened if we had used a logarithm? Okay, well, here's what we would have done. Log of 2 to 3x plus 13th equals log of 128. All right, this would have allowed me to take the 3x plus 13 to the front in parentheses times log 2, using that property there. And this would have been log 128. Okay, we're not going to distribute the log through. Instead, we're going to divide off the log on the x side, on the left side. So log 128 over log 2. So I end up with 3x plus 13. Get my calculator out. Log 128 is about 2.017 something divided by log 2. 7. And then from here, it becomes the same problem. So 3x equals negative 6. Divide off the 3, divide off the 3, x is negative 2. Okay, see how I am on board space. Okay. Here's an example 2. I get my examples off my document off camera, so I'll be back in a moment. 9 to the x plus first equals 27. Sorry, 27. To the x minus fourth. Okay? Both of these are powers of 9, or powers of 3. So 9 is 3 squared. I'll put the original exponent in parentheses. Okay? I'll do that again. Now repeat this. Both of these are powers of 3. 9 is 3 squared. Put the original exponent in parentheses. 27 is 3 cubed. Put the original exponent in parentheses. Okay? This allows me, since this equals this, and the base equals the base, that requires the exponent to equal the exponent. I'll go ahead and do the distributive property. 2x plus 2 equals 3x minus 12. Okay? I got x's on both sides. I don't like that, so I'll subtract the 3x. X plus 2 is negative 12. Subtract your 2, subtract your 2. X equals negative 14. Okay? Again, a logarithm could have worked. I could have used a logarithm, but we'll skip the logarithm. Log is an option, but not done this time. Log is an option, but we're not doing it this time. Okay? So I'll pause here and I'll set up another example. Okay, now what I have done is I kept example 1, I've erased example 2, and I'm putting example 3 on the board. Okay? So, do. 5 and 26 are not convertible to a common base. So what we're going to do is we're going to do the logarithm. Okay? So I'll have log of 5 to 4x minus first equals log of 26. Okay? That will allow me to take this to the front as in parentheses. All right? And then we're going to divide the log on the left side. All right? Cancels over here. We have 4x minus 1 equals log 26 over log 5. Okay, and then we're going to add 1. So I'll have 4x equals log 26 over log 5 plus 1. Okay, next I need to divide off the 4. I'll be dividing all this over 4. So that leaves me x equals log 26 over log 5 plus 1 over 4. Okay? Put another way, let me go ahead and move that up a little higher. X equals log 26 over log 5 plus 1 over 4. Or another way you could have put this is x equals log 26 over log 5 plus 1 divided by 4. That's another way that could have been expressed. Okay? Now the approximate solution, so these are exact. And now I'll do an approximate. X is approximately equal to one thing at a time. Log of 26 is approximately 1.41497 blah 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 divided by log of 5. I have 2.024 blah blah blah. Add 1, hit enter or equal. That's 3.024 divided by 4. approximately 0.756. This is approximate. Okay? All right. I'm going to stop here, pause here, and clear the board. Okay. Example 4, we're going to solve e to the 0.015x power equals 14, and that's what we're going to use right there. So I'm simply going to take the natural log of e to the 0.15x equals the natural log of 14. Now, this is equivalent to log base c, okay? ln is log base c. So, log base c of e to a power simply takes the exponent out of the exponent. All right? Next, we simply divide off that 0.15x, or that 0.15. And x is approximately, because it says round to 1 decimal place. I'm going to take the natural log of 14. I get 2.639 blah 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 divided by 0.15, and the value rounds to 17.6. Okay, here we're going to have to divide off that 12. To isolate the base. Okay? So that leaves me e to the 0.05t equals 6. All right, same as before. It's base e, so we're going to use a natural log. All right, since that's log base c, that allows us to take the 0.05t out of the exponent. The final step is to simply divide off the 0.05. Okay, I'll try to make that more legible. Natural log of 6 over 0.05. Cancel those, and t is approximately, because it says to round. I'll take the natural log of 6. I end up with 1.791759 blah 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 divided by 0.05. I end up with approximately 35.835. Okay. Neither one of these two problems asks for the exact value. It wanted us to round. I asked to round a certain number of decimal places. This problem, we are going to give an exact value and a rounded value. Okay? So do. It's e to a power equals a number, so I'm going to take the natural log of e to the 2x plus first equals the natural log of 15. That takes the exponent out of the exponent. Okay, now I will subtract the 1, and I end up with 2x equals the natural log of 15 minus 1. Divide off the 2, divide off the 2. Natural log of 15 minus 1 over 2. Don't combine those because they're unlike terms. Okay? So, x equals the natural log of 15 minus 1 over 2. This is an exact solution. Also called a rational form. Okay? Irrational form is another way this would be put. Okay, B. X is approximately, so I'll take the natural log of 15, hit enter, equals natural log of 15. I get 2.708, blah, 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 subtract 1, now it's 1.708, blah, 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 then divide by 2. I get x is approximately 0.854. By the way, this is also called irrational form. So we can call this exact solution. We could call it irrational form. Okay, both terminologies are used to describe that situation. Both of these describe an exact solution of a logarithm. Okay? Exact value, exact solution, and irrational form. All right, so I'm going to take this, I'm going to stop here, pause here, take all this off the board and do another example. Okay, the main event for right now is going to be example 7. Okay, but we're going to go back to example 3 as a review before we take on this problem. Okay, 5 and 26 are not writable in terms of a common base, so we're going to use the common logarithm. Okay, so I'll take the common log of 5 to the 4x minus first is log of 26. Allow me to take the 4x minus 1 to the front. Okay, now the next thing I did was divide off the log on the left side, leaving me, those cancel, 4x minus 1 equals log 26 over log 5. Next thing I did was I add my 1. I had 4x equals log 26 over log 5. And then divide off the 4. So x equaled log 26 over log 5 plus 1 all over 4. Okay? Now, what we're going to have to do here is take the log of both sides. So, log of 5 to 2x plus first equals log of 6 to the x minus second. And these are going to the front. So I have 2x plus 1 log 5 equals x minus 2 log 6. Okay, similar to what happened here. Okay, except on both sides. Now, like I did here, I'm going to go ahead and divide the log 5 off this side, off the left side. And they'll cancel over here, and I'll end up with 2x plus 1 equals that. Okay? Now, what I'm going to do here is I'm going to go ahead and do the distributive property. So this is going to be x times log 6 over log 5. So distributive property time. Okay? Minus 2 log 6 over log 5. Okay? So on this side I cancel, on this side I distributed. Now, the goal here is to get the x's to one side. Get x's to one side and isolate. Okay? So the idea here is I got x's on both sides. I'm going to get rid of the one that's on the right side. All right, and I'm going to subtract it from the other logarithm, or from the other x term. So I'll have 2x minus x log 6 log 5 plus the 1. So this x term minus that x term plus the 1 equals, negative 2 log 6 log 5. Now, the next thing to do was to isolate the x terms. So I'll subtract that 1 because it doesn't have an x term in it. So now I have 2x minus x log 6 over log 5 equals negative 1 minus 2 log 6 over log 5. Okay, I'm going to go ahead and copy this up here. I want to make sure that it all fits on camera. It does. Okay, good. Now, what I'm going to have to do next factor out x and divide. Okay, so that's the next step. Factor out the x and divide. So these two have an x in them. I will take it out. And finally, I'm going to divide it off this, I'm going to divide it off that. So x equals this over this divided off here, divided off there, and became a denominator. And we can call that done. I have two more examples here. For both of them, I'm giving the exact solution, and then I'm approximating it to 2 decimal places. So we'll start with this one. This is 9 to the 7x power times 13. That's equivalent to 7d8. So the first thing we have to do is isolate the exponent base. So I'll divide off the 13, and I end up with 9 to the 7x power is 6. Now 9 and 6 cannot be rewritable, or not rewritable in terms of a common base. So we'll use the common logarithm. So I'll take logarithm 9 to the 7x power equals log of 6. That allows me to take the 7x to the front. So I'll have 7x log 9 equals log of 6. Okay? Like the previous problem, I'm going to divide off the log that's on the left side. These cancel, and 7x equals log 6 over log 9. Okay, all I'm going to do is copy the problem over, the problem at this point up here. And continue. I have 7x, so I need to just divide off that 7. Now, instead of putting in the denominator, I'm going to actually use an arithmetic division symbol. So x equals log 6 over log 9 divided by 7. Okay, and I want to make those division symbols more clear. Alternatively, you could also describe this as x equals log 6 over log 9 divided by, well, or log 6 over log 9 over a bigger fraction bar in the 7. Now, we're going to do b. So these are the exact values, either this or this. Okay, your choice. This is more calculator friendly. So I'm going to take my calculator, log of 6, that's approximately 0.778 blah 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 divided by log of 9. I have 0.815 or 0.81546 blah blah blah, then divide by 7. Okay, so my calculator spits out 0.1164948 blah blah blah, who cares? Okay, so it wants us to round to two. We're supposed to round to 2 decimal places. That's second decimal place. That's a 5 or greater, so we're going to x equals 0.12. Okay? All right. This next one, like before, I need to isolate the base and the exponent, so I'll divide off that 55. So I end up with 7 to the x plus 9th power is 2/11 when that fraction is reduced. Okay? Like before, I'm going to use the common logarithm. And now I'll take this exponent to the front. And I end up with x plus 9 log 7 equals logarithm of 2/11. Okay, and like before, I'm going to divide off the logarithm on the left side. Like so. Okay, these cancel. That's what they're supposed to do. We end up with x plus 9 equals log of 2/11 over log 7. I'm going to copy this exactly as is up here. All right? So x plus 9 equals log of 2/11 over log 7. The final order of business is to subtract that 9. So x equals log 2/11 over log of 7 minus 9. Okay. Now, next I'll do B. So, I'm going to type in log, open a parenthesis if your calculator didn't. So for this one, you're going to need to open a parenthesis if your calculator didn't. So 2 divided by 11. Close the parenthesis. So log of 2/11 in parentheses, I have negative 0.74 blah, 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 blah for just this part. Negative 0.74 divided by the log of 7. Now I have negative 0.876 and subtract the 9. Negative 9.876 blah 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 blah, who really cares? Second decimal place, I'm rounding up. X is approximately negative 9.88.